Okay, so this is 8.1 and 8.2, counting principles and permutations. We're going to split the lesson into two pieces, so we'll do 8.1 as this lesson. The first thing you got to know is we are going to be using this little symbol here, this exclamation mark. It's known as factorial, so you would read this as 5 factorial. And all that means is if it was 5 factorial, it's 5 times 4 times 3 times 2 times 1. It's just a shorter way of writing out longer multiplication. So for instance, 10 factorial would be 10 times 9 times 8 all the way down to 1. So what we can do is sometimes we'll be dealing with factorial that you can do without using a calculator. Like look at this big one here, 87 factorial divided by 85 factorial. So you can't put that into your calculator because it will not be able to do the math, right? It just can't handle it. But what we can do is we can take 87 factorial and break it down to 87 times 86 times 85 factorial. Oh, stop right there, right? You can see the 85 factorial. So if you see that top and bottom, you can reduce them. They reduce down to 1. And then all you have is 87 times 86, and you can do the math on that one. Okay, the next one over here, the 21 factorial divided by 17 factorial, 4 factorial, right? The 21 we can break down, keep going down, 21, 20, 19, 18, just go down to 17, right? Stop there, because you can see there's going to be a 17 in the numerator and the denominator. And what we did with the 4 is we broke the 4 down into 4, 3, 2, and 1. And you'll see in a sec why we did that. Okay, so the 17 is reduced down to 1. Then we could look at, 4 goes into 25 times, 3 goes into 21 7 times, 2 goes into 18 9 times. And then we just do our multiplication across the top here. 7 times 5 times 19 times 9, and then you get your answer there. Now that's just with straight numbers. You can do the whole concept with expressions also. So in this case, right, we have up top here, n plus 3 factorial. And you just got to think what that means. We are going down every time. So we can break that down to n plus 3, n plus 2, n plus 1. And you can see we're going down in the values of n. And then the last one would be n factorial. And then, oh, yeah, we can reduce n factorial from both the numerator and the denominator. So we end up with just those 3 binomials. And you can leave them in that form. So now, what we want to talk about is the first concept after factorials is the fundamental counting principle, right? And this, what we're talking about here is probability in essence, right? So what's going to happen is you can do something m ways here. The first action is m ways. The second action is n ways. Then the 2 actions can be done in m times n. That means multiply. So what we got here is, let's look at our first example. We have 225 students. And we're going to choose valedictorian, a salutatorian, and a class historian. And no more than one person can hold any of these offices. So here we do. We have 3 spots: first spot, second spot, third spot. So valedictorian, salutatorian, class historian. So the first option, 225. One of those people is gone, so now we can do 224 and then 223. So what it is we want to know how many different ways there are picking those 3 people. Well, there's like 11 million ways. It's a lot. Okay? Here. How many ways can the letters math be arranged? So there's 4 letters of math, and we can arrange them any way we want. So the first one, 4 different ways. One of those is gone, so now you have 3, and then 2, and then 1, or 24 ways. Now you could have shortened that up by writing 4 factorial. That would have worked also. Okay. Next page here. Rule of sum. If a first action can be done m ways and a second action can be done n ways, but only one of these actions, so that means or, either the first action or the second action. When you see that, it means add. Different than the last one, which was multiplied, and that's and. So for or, it means add. For and, it means multiply. So pizza day. You get a choice of 3 flavors of ice cream or 2 kinds of donuts. So your options are, hey, there it is. You either get the 3 flavors of ice cream or the donuts. You can't have both, and that's why you add them, right? So if it's or, it's add. And here, if it's and, multiply, and again, or add. Just keep that in the back of your mind, okay? So now what we can do is we can talk about actual permutations. And permutations is a combination of all this stuff. So it's the arrangement of items, and order matters, right? So the arrangements of letter ABC and ACB are different. That's what a permutation is. The order matters. We'll get to something where order doesn't matter, and that's a combination, but that's coming later up. So here, how many permutations can be made of the letter try? So and you can see all the permutations here, right? Because order matters. So 3 for that first one, 2 for the second one, 1 for the last one. So 6 ways, right? You could do it out with all writing this. But the problem is you get a word like with 11 letters in it. Do you really want to write out all these different permutations? No. I'll show you the math that goes with it in a sec. Here's one here. We have the letter count, the word count. There's 5 of them there, but we want 3-letter arrangements. So 3 letters, there's our 3 lines, 3 letters, right? 5 for the first one. One of them's gone. Now we have 4. Now we have 3. So 60 ways. Now, that is the fundamental counting principle, but you can also just use the permutation formula. So here's the permutation formula. It's NPR. So it's number, pick however many you want, right? And then it's just n factorial over n minus r factorial. So that is a button on your calculator if you want to look for it. If not, you can do it manually. So for instance, example number 2 here, we had 5 letters and we were picking 3. So if you look here, yeah, 5 letters, pick 3, 3-letter arrangements. So then you can just plug in the math. 5 factorial over 5 minus 3 factorial is 5 factorial over 2 factorial. Reduces down, you get your 60. You can see we did it both ways, right? We got 60 up here and we get 60 down here. So it doesn't matter to me which way you do it. Fundamental counting principle or the permutation itself. Example number 1, if you remember example number 1, we have 3 letters and we're picking 3. So it's 3 pick 3. I know it sounds weird, but 3 pick 3. So 3 factorial over 3 minus 3 factorial is 3 factorial over 0 factorial, but we still have to get the answer of 6. So what that tells us is when you have 0 factorial, that actually equals 1. Okay, keep that in mind because it's really, really useful. Okay, flip the page, let's go to example 3. 8 pick 5. Again, 8 pick 5, we can use the formula. 8 factorial over 8 minus 5 factorial is 8 factorial over 3 factorial. And we can do our breakdown. So it's 8 times 7 times 6 times 5 times 4 because the 3's reduce and they get your answers there. Now that's with numbers. Well, the cool thing about the way factorials work and with permutations is you can handle them without numbers. So let's look at this algebraic expression here. So n pick 4. Now I know these has equal signs, so technically this is an equation, but I was just using it to divvy it up here. So now think about what factorial means. Factorial means you're going down. So we can take this n factorial and we can just actually work it through and go down. N minus 1 is the next one, then n minus 2, n minus 3, and then n minus 4 factorial. Stop there because you can see those two pieces reduce. And then we're left with just this big old expression here at the bottom. So you can work it through even if there's not numbers. Okay. Now, when you have counting arrangements, you sometimes have special conditions, and those always have to be filled in first. So look, we got Harry, Sue, Alice, Bill, and Connie go to the movie. So we want to know how many ways they can be seated if boys and girls alternate, right? So if you look at this right here, boy, girl, girl. Okay, that wouldn't work. So that is not a possibility. So the only possibility is girl, boy, girl, boy, girl, right? So then we look at here, how many girls do we have at the beginning? 3. How many boys? 2. Now, how many girls are gone next? Well, only 2 now because one's been taken in that first position, right? 1 boy left because one of them is already used in the other spot, and then 1 girl at the end. So 3 times 2 times 2, right? So 12 ways. Now, you can also look at it slightly different. You could arrange the girls in different ways. There's 3 factorial ways to arrange the girls, and you can arrange, there's a E missing there. You can arrange the boys in 2 ways. So then you can also do 3 factorial times 2 factorial or 12 ways. Either way is acceptable for getting an answer like this. Okay, so that is 8.1. What we'll do tomorrow is, or the next lesson is 8.2. We're going to talk about permutations with restrictions. And what it has to do is with repetitions. Okay, so wait for that lesson.